Now that we've installed our prerequisites and the Fabric samples directory itself, let's familiarize ourselves with Fabric. And in order to do that, we're going to get started with running a test network, which again, we're just going to follow what's on the read the docs. And we're just going to, so again, this is just to read the docs on the left side of your screen. And on the right side is I have my Ubuntu WSL pulled up. All right, so we're gonna first navigate to my Fabric samples directory, which I installed and showed you in my last video. And so we're now in our Fabric samples directory, and we're just gonna follow the simple instructions here. But before we do that, let's just see how the Fabric test network is structured. And the way it's structured is that it includes two peer organizations. Now, again, I would highly encourage viewers to go check out the glossary, check out the key concepts, just to understand what a peer organization is, what an ordering organization is, because that exceeds the scope of this video. This is more of an instrumentation video and playlist that I'm going to create right now. So again, you should familiarize yourself with all these things just so you know what's going on. There's a single ordering service, and specifically a single node that comprises the ordering service. There's no certificate creation we have to worry about creating, and the network itself comes with the Docker compose, and it's isolated therein. So as we start up the network, let's also bring up our Docker GUI so we can see in real time what's happening. So I'm going to keep this. So we've got our doc on the left, our Ubuntu in the middle, and Docker desktop on the right. Okay, so let's go ahead and get started. And the first thing we're going to do is we're going to navigate to our test network. We have all these different files and folders. You are going to be using this script in particular, so let's just see what it really is doing. And let's make our network a bit bigger. Oh, we can't. Okay, so let us just run the network with some help. Okay, so we see here all the different options, right, when we have our network script. And these are the different flags we can use it with. And these are the different modes that run with the flags. So, you know, good stuff for you to read. The first thing we're going to do is just, follow the instructions here, which says just to make sure that we don't, have any prior instances running of the network, let's just bring everything down. Now, of course, I don't have anything running, as you can see on my Docker on the right, but nevertheless, let's just see what happens when I run the down mode. And it just, removes everything, although nothing was created, which is why you see it's very fast. It happens in, pretty much instantly. So now that we've done that, we're just following the documentation on the left, right? Let's run the network. And we're going to do that the same way we shut down the network, which is just bring it up and keep a close eye now on the Docker desktop GUI. I'm going to make this a bit smaller. And let's see what happens over here as soon as we create the network, the test network, using the network.sh script. So I'm going to allow this. Now you see there's a compose network. It's running. And let's just make this bigger now. We have an organization 1 and a peer node from organization 1 that's created. We have a peer node from an organization 2 that's created. And we also have an ordering service, specifically from the ordering organization, right? So we've got these 3 different organizations, and we've got 1 peer node each from the organizations that we intend to, write smart contracts for and with and validate transactions therein. And we have that 1 organization that's going to be ordering. So this is the simulation of the organizations in your test network itself. And you can see they run on these different ports here. This is their CPU consumption and when we started these different containers that are isolated within the specific composed network. Okay, so let's take that back. Now that we have this running, we can minimize this just because it's not really adding any value there. Let's go back and see all that happened as soon as we ran the network up. the first thing it did is it created these nodes, and it generated the certificates using the CryptoGen tool. What is the CryptoGen tool? Well, actually, uh, so if you see here, if you go into the binary directories, so the bin, you see all these different files. These are all binary files, and CryptoGen is just one of them. And you need to use the CryptoGen binary to actually generate certificates for the different organizations, org1 and org2 that it created, and of course the ordering organization. These are the different volumes that were created and the containers based on those volumes. And again, you have these different container IDs, images, commands, and that's essentially what's going on. Now, another way to check out your Docker containers is to use the Docker on the command line, which again will give you pretty much the same information. If I just make this bigger, it looks neater. It gives you the same information as the Docker desktop GUI, so it's interchangeable, right? You can either use a GUI or you can use your command line. It's all the same stuff. The GUI will make it easier for file I/O, as you'll see later in the playlist, but for now, let's just ignore that. So let's clear our terminal, and let us now move on to actually instrumenting different things we can do with the network. So in order to do that, let's bring up code. So let's open code in our current directory, which is Fabric samples. All right. So I'm not going to minimize my terminal because we're essentially running code here. And again, keep in mind we have these containers already running, peer 0 from org1, peer 0 from org2. These are different organizations and each have a peer node and of course an ordering node, which comprises the entire ordering service. All right. So I can also now open a terminal where I am. Again, this is just another terminal. Make sure you're using the bash terminal. So again, we're going to leverage the create channel mode from the network.sh, but let's just dig in to see what that actually does. And in order to do that, we're going to open that network.sh file right here in our code, and we're going to find the create channel. Create channel. So this function is the create channel function. And let's dig into what it's doing here. So this is the function definition, right here. And you can study this as you want, but essentially what it's going to do is we're going to create a channel. Now I can give a channel a name using this -c argument, and I'm going to call it channel 1 just because we're following the documentation here. Calling it channel 1, and it automatically adds existing peers that are created from the different organizations into channel 1. Of course, because this is a test network, it automates a lot that you need in order to make this happen yourself if you were not to use a test network and deploy your own production network. But this is simple, so we're keeping things simple. And essentially what it's doing here is it's created a channel, and if you recall and you read the documentation for Fabric, each channel has a channel specific ledger, right? And the ledger consists of two things, which is your blockchain and your world state. So it's created the blockchain inside my ledger for channel 1, block 0, which is a config block, and it's dispersed that block to both peer nodes in my organizations. Okay, and it's done all these things, so we're good. Now, these are the different rules you need to follow when you're creating channels. The next thing we're going to do is we're going to start a chaincode on the channel, right? And chaincodes are packaged smart contracts. Smart contracts, as the Fabric developers have created their nomenclature is essentially the Go file itself, like the actual file of code that you write. And the chaincode is the packaged version of that file that you need to install onto your channel, i.e. peer nodes, right? So let's go ahead and do that. Again, the network.sh file provides this function deploy cc. So if we find that on our network.sh file, let's see what this is doing. It's a very small function, as you can see. It's essentially just, giving it these arguments that it makes up and installs the given chain code that is provided to us because of the test network we're using, and installs it onto the peer nodes that are within channel 1. Okay, so if I just copy this command, and I'm gonna create another file here just because it makes it easier. So I'm going to create a new file in my test network directory, and we're just going to call it commands.txt, and we're going to go over this command really quickly. So what it's doing here is we're giving the chain code to deploy a name, and we're naming it basic. Then we're giving it the path of where the chain code that we want to name basic actually resides, and that chain code actually resides right here, one directory up from test network. So one directory up from test network. So we're going to go one directory up, and it's called asset transfer basic, and it's inside the directory chaincode-go. So this entire directory is basically packaged in to a chain code called basic, and the language of the chain code that is written is Go, which is why we're specifying Go here, CCL, right? So let's check out what is actually going on here. So we have an asset transfer.go, right? And then if you go inside chain code, we have a smart contract.go. So let's open that as well. So you can get rid of that, and we'll get rid of this window for now. Now again, this is the smart contract that's actually being packaged into chain code. And we're just going to install the Go extension so our VS Code IDE can better interpret what's going on when you open a Go file. Okay, so we're going to reopen that smart contract, which is what we're deploying. Okay. Again, this command is automating the conversion of this Go file into a packaged chain code and deploying that chain code onto our peer nodes. So let's study this chain code really quickly. So it, imports whatever is necessary, creates a smart contract struct, which it then, is defined better here. And this is the asset struct. So again, this is just provided to us from the Fabric samples directory that we install. This is just a template for you to create your own smart contract later. But essentially, the struct has these different details: appraised value, color ID, owner, size, and you can see the different types therein. Strings, ints. There's init ledger function, which initializes your ledger in your channel wherever this chain code is going to be deployed once you call this init ledger function with these assets, right? Then you have a create asset function. So just like you have these assets that are already created explicitly here, you can actually create them through code by passing this specific arguments here, right? You have a read asset, you have update asset, you have delete asset. This asset exists, so this is gonna return true, false. You have a transfer asset where it's essentially transferring the ownership of a given asset. So as you can see, when you go back to your asset struct, you have an owner detail right here, right? So you can actually change that using the transfer asset function. You have get all assets that should return all the assets found in the world state. Again, the world state is one part of the ledger that's residing in a channel on specific peer nodes, where the second part, of course, is the blockchain. But the blockchain itself does not provide an easy interface for interaction compared to the world state, which does. Right, and we'll go into more granular detail throughout the course of this playlist, but right now we're just with our feet wet with the test network. So let's go ahead and start interacting with the network. So we're gonna copy this command, which I have right here, and we're gonna paste it onto our terminal in VS Code. So let's clear our terminal, and I'm gonna copy this command. Now again, what that command is going to do is essentially package this Go file into into a chain code and deploy that chain code onto my peer nodes. Okay, so let's see what's going on. So first it has to vendor all these Go dependencies, package my chain code, install the chain code on peer0.org1. So let's wait for it to do that. This is a specific command that's actually installing this basic chain code, because remember, we renamed this chain code into basic. It's done that successfully on org1's peer node. It's now doing that on org2's peer node. Same exact thing, right? It failed. Now, why did it fail? Well, it failed because by default, the channel name is my channel. But recall that when we created a channel in this network, we named it channel 1, right? So if I redo this, -c, so if we give it -c channel 1, and then rerun this, let's see. Now it's able to install the chain code onto channel 1 because channel 1 actually exists. Remember, my channel doesn't exist, and that's the default name of channels unless you specify it with the channel flag. All right. So you can see that the chain code was also automatically approved by org1's MSP and org2's MSP. Note that we didn't have to specifically go ahead, simulate each of those organizations and manually approve, because it's, again, a test network file that we're leveraging, network.sh, and it does all that for us. This is not very realistic and definitely not going to happen in a production production deployment. But again, we're just getting our feet wet here. All right, so we've successfully installed this chain code onto channel 1 called basic, right? And specifically, it's this smart contract that we packaged in a chain code. Okay, we're going to get rid of the network.sh. Actually, we'll keep the file. Why not? The next thing we're going to do is we're going to start interacting with the network, because we've installed the chain code, we've created a channel, and now let's actually use the chain codes. So first thing first, we're going to, again, clear all this. We now need to actually, in order to invoke transactions using our chain codes, we actually need to be an organization, a peer node from a specific organization, right? So you go back. So far, we're just, on a terminal, but we're not actually simulating any specific actor within this network. We're just on a terminal. We're just, sort of this admin personality. But let's actually now change and become a specific org. And in order to do that, we have to be a peer CLI. So you actually have to copy all these commands into your terminal. And just to make sure this is, in our current session, if I echo the environment variable this, for example, it is okay, just for verification. So now let's actually invoke a command. And specifically, we're going to invoke the init ledger command. So I'm just going to copy this back into our commands directory. Let's take a look at this. So peer chain code invoke, first of all, who are we? We've set ourselves to be a peer node from org1, right? So we're currently simulating as this guy right here, right? Peer 0 org1, okay? And we're invoking a chain code targeted to our ordering service, blah, blah, blah. These are just sort of config arguments that you have to put in. But this is the main part of this, is we're using this function, we're calling this function from our chain code called init ledger. So let's go back and see what init ledger is doing. which we went over previously. So we're going to go to init ledger. So this is the function we're calling, right? And init ledger basically initializes the ledger with these 6 assets, right? But just to make sure that I have an empty ledger right now, let me first go ahead and call the get all assets function. So get all assets. So let's see what get all assets is doing. So you see get all assets just returns all the assets that are stored in my ledger. So I'm going to go ahead and do that first. Again, same problem as before. We gave our channel the name my channel 1, but over here they've given it my channel. So we have to change that argument. So let's call that, again, channel 1. And no response, right? Because it's an empty response because our ledger is empty. So let's go ahead and initialize our ledger with the way it's defined. Now, just you can see that this query is not as involved as the pure Chaincode invoke query for the init ledger, right? So if we go ahead and do that, fail to invoke, same problem. So we actually, let's just change the channel name here. Let's see, does it actually state my channel anywhere? Change that to channel 1. Copy that, paste it. Okay, Chaincode invoke successful with a status response of 200. So again, now when I run my get all assets function, boom, right there. And you can actually pipe it to JQ, just it returns a nicer JSON formatted output. So this is the same output. I'm just piping it to JQ to get a better, prettier output. So let's compare this output to our actual smart contract init ledger function just to make sure it's the same thing, right? So when I go back to init ledger, asset 1 has the following details, right? And if I go, what do I see? The first asset loaded in my get all assets function is 300 asset 1 blue size 5 owner Tomoko. Same thing for asset 2 red Brad 400. So it matches everything, and it's the same thing here. It's just a little uglier, but it's essentially the same, virtually the same output, right? Okay, so we've called the init ledger and we've called the get all assets before and after to prove that init ledger is actually doing something. Now let's transfer ownership of a specific asset right here. This is the next command. We're now going to call this command, and the first thing we're going to do is change the channel name because we decided to name our channel 1 instead of the default my channel. And specifically what's happening here is we're calling the transfer asset function and giving it the arguments asset 6 Christopher. So let's go to transfer asset now, and let's see the arguments it requires: ID string and new owner string. Now this is a default pass argument already, so we don't have to worry about this. This is defined earlier in the file. But anyways, we're looking at string of an ID, which is asset 6, and the new owner Christopher. So let's go back because this is an init ledger asset, right? So let's check out asset 6. So asset 6 is currently owned by Michelle or Mikkel, I don't know how to, and asset 6, yep, size 15. So everything should be the same, right? Except for the owner after this command is run. So let's go back, format this command right, so we can just paste it in. Successful. Payload, this is basically the sort of git diff, if you will, right? So if we go back now to get all assets, pipe it to JQ, boom, we have asset 6 from Michelle to Christopher, right? Okay. Now, this section is quite important. The transaction is automatically signed by orgs 1 and 2 in the test network, right? And let us now, so far we've been simulating as org 1. Now if we copy all these environment variables and reset them accordingly, we can now simulate being org 2. And just to verify that, if I echo this newly changed environment variable, it returns org 2 MSP. So let us now run a pure chaincode query posing as org 2. Again, we're going to have to change the channel name, channel 1. And we're going to read asset 6. So, right, it returns exactly what we expect. And now that we've done all this, let's bring down the network. So let's see what happens to our Docker compose once we bring down the network. We have all this running, right? We have all these things, different things running, but if I all network sh.down, all our, everything in our compose network goes away. And we're ready to start a new network afresh. So that was a summary of us actually bringing up a test network and interacting with it using peer zeros from org 1 to a default ordering service.